This presentation is delivered by the Stanford Center for Professional Development.
So today's going to be a little slide-heavy day because we didn't have the vote so far, but we'll try to do some more board stuff as well. So here's the class hierarchy you saw before. And we covered a lot of the class hierarchy last time, but there were still a few bits that we have left to cover, which is G-image, G-polygon, and G-compound. So you'll see those, and then you'll be ready to do all kinds of cool stuff today. As a matter of fact, today we're going to break out things you can do with the mouse and more graphics kind of stuff with the mouse, and it's just a whole bunch of fun like you'll be doing in breakout. Okay? So G-image. All the G images, and this is a funky way that you can put pictures inside your program, like pictures that you take with a camera or whatever, or your phone, you can just stick them in your program. And the way you do this is there's a class called G-image. And so you can create an object of type G-image by saying new G-image. You give it the name of the file, okay? That's the full file name that, with a dot and whatever ending it has. And then the XY location for where you want to display that image. The XY is the upper left-hand corner of the image. Okay, so the image file is the name of the file containing the image, and X and Y, as I just mentioned, are those coordinates. Now, where do you have to stick this file? That's something to remember. So when it looks for this file, what it will do is it will look in your current project folder, and if it does not find that file name in your current project folder, then it will look in a subdirectory named images. Okay, so you can have a subfolder if you have a whole bunch of pictures called images inside the folder for your project. Put all your images there. It will also look there as well. If it's not in either one of these places, bad things happen. And if you want to know what bad things happen, you can actually try it. But I wouldn't, encourage you to just try to do bad things. So just stick it in the folder with your project, and you'll be fine, and you'll get the image. So let me show you an example of what that actually looks like. Just so you know, both GIF or GIF format. Some people say GIF, even though the G stands for graphics over here, which is kind of a hard G. And then JPEG, which is another graphic standard, and you'll see the ending for files either .jpg or JPEG, which is just another format. Both of them are supported, and so most cameras or phones or whatever actually end up taking pictures in one of these formats. So here's a simple example. So if we had some program run, we can say I want to have some image that's a G image. So I create one, and let's say I have the Stanford seal, which hopefully we have rights to, I would hope. It's probably like some guy in Kansas actually has rights to the Stanford seal and charges every time we use it. It would not be the first time something like that has happened, but that's not important right now. What is important is that stanfordseal.gif, right, it looks for that file inside the folder for our project, and then it's going to we're going to add that particular image at location 00. So here I did it the way that I just specify the file name without giving the X and Y coordinates. You can give it the X and Y coordinates if you want to begin with, but if you don't, it's kind of funky to say, hey, load that image, and now I can get like the size of that image so I could center it in the screen or whatever if you want to do that. You can also, what's also sort of fun is you can remember G-image implements this particular interface called resizable, okay? So we can actually say, hey, image, I want you to scale like 1.5 times in the X direction and 0.5 times in the Y direction. It's kind of like Stanford comes to school and checks into the dorm and gets on the meal plan and puts on the freshman 15. It's just like, oh, I'm fat at Stanford now. But you can take for pictures of your friends and just distort them in funky ways. It's just a good time. Okay? So you can do all kinds of a bunch of different options on things like images. That's just one of them. Okay? There's also this class called Polygon, and Polygon's kind of a fun, kind of interesting, cool class. And what it lets you do is it represents graphical objects bound by line segments, right? So we need to get a little bit more formal. But here's like a little diamond. Here's a hexagon. They're just polygons, right? And all a polygon basically is just something that has multiple sides on it. That's where poly comes from. It just means many, okay? So the basic idea that's interesting about polygons is a polygon has a reference point. Okay? So when I create a polygon, I'm actually going to tell the computer sort of all the points on the polygon. All of those points that I specified, like let's say the 4 corners of a diamond, are all in some relation to some particular reference point that I pick. And so in this case, I might, for example, pick the center of the diamond. And in fact, in most cases, all of the vertices that I lay out, since they're going to be relative to some reference point, that reference point, often it's convenient to pick the center. Okay, it just turns out, it doesn't have to be, right? You could actually have your reference point be like upper left corner of the bounding box or whatever you want. You just got to make sure that when you sort of tell it what the vertices are, you lay them out in the right order. But oftentimes the center of the polygon, if it's a regular polygon, which means it's sort of symmetric all around, then the center is often easiest. So I'll show you some examples of this, how you actually construct one of these G-polygon objects. Okay? So first thing you do is you say create an empty polygon. Okay? So you create an empty polygon object. And then what you're going to do is you're going to specify the vertices of that polygon one at a time using a method called add vertex. And add vertex is going to take an x and y coordinate. These x and y coordinates are relative to your reference point. So if you think of your reference point as being the center of the object and you say, oh, my x, y is 1, 1, that's 1 pixel over and 1 pixel down from wherever you think of your reference point as being. You never actually specify the reference point to the G polygon. The reference point's just in your mind. All of the vertices are just relative to whatever reference point you happen to pick. And I'll show you an example of this to make it concrete in just a second. After you set an initial vertex, so you need to set the first one with something called add vertex. After you set the initial vertex, you can set all the remaining vertices in one of two ways, because we just give you options. We like you. One way is just to keep adding vertices. And when you call add vertex again, what it does, it adds a new vertex, again, relative to the reference point, and it essentially creates an imaginary line between the last vertex you just added and the new vertex you added. That's how you're getting edges of your polygon. You're sort of specifying the corner points. Another way, instead of specifying corner points, after you've specified the first point, you can explicitly add edge. And add edge adds a new vertex relative to the preceding one. And here, it's going to do it with offsets of dx and dy. So relative to where we were before, we actually specify sort of an offset in the x direction, offset in the y direction. It's kind of like you were almost creating a line, and it's going to add an edge. This one's using absolute coordinates relative to the reference point. That's kind of the key difference between these two things. And I'll show you an example of both of them. Okay? One final thing you should know is the polygon is in some sense closed for you. So if you're drawing a diamond, and let's back up so I can show you the diamond. If you're drawing a diamond, you might specify that as the first vertex, then this is the second, then this is the third, and then this is the fourth. How does it know that the fourth and first are what should be attached to each other? It just closes it for you. So after you've added the last vertex to the polygon, basically what it does is it just automatically sort of links up the first and last segments or first and last vertices to sort of close the polygon for you. That's how you actually specify it. So you never actually need to go back to the first vertex again. It just does it. So that's kind of a whole bunch of stuff in theory. What does it look like in practice? Okay? So we're going to create a diamond. We're actually going to create it using some method that we'll see called create diamond. And so when we call create diamond, we're expected to give us back a G polygon. Here's where all the interesting stuff's going on. So here's the create diamond method. Create diamond is going to return a G polygon, so it needs to create one because it's going to return it back to us. And what it's getting is the width and height of what that diamond should look like. So the first thing it does is it says create a new polygon, right? It creates a new empty polygon just like you saw before. Then what does it need to do? It needs to add the first vertex. So it adds the first vertex, and it's going to do this relative to some imaginary reference point that I pick. The reference point that I'm going to pick is going to be the center of the diamond, which means my first vertex in the x direction is going to be minus width over 2. So let me just show you where that vertex would be. So if I think of the imaginary center and I just executed that line to add a vertex, I would say relative to my imaginary center, my first vertex is at half the width of the diamond over in the negative x direction and on that same line, so 0 in the y direction. Okay? Then where do I go from there? Well, I'm going to add the next vertex. The next vertex that I'm going to add relative to my center is going to be at the same x coordinate as the center, but it's going to be minus height divided by 2 upward. So what I get essentially is this is the next vertex, and it just kind of creates the segment in between them. Whereas my next vertex, it's going to be over here. It's width divided by 2 from my imaginary center point, okay? And on the same line as the imaginary center point, so the y offset is 0. And then last but not least, the last vertex I'm going to add is on the same x coordinate as the imaginary center, but the height is half the height of the diamond downward. So I get that. And now if I say return diamond, it matches up the first and last vertex. So what I get back is a closed polygon. I actually get that diamond, and that's what's returned back to me in my run function over here. So diamond is now this little polygon. Question? It depends on if you do something like add edges versus add vertex. So again, I would try it, and especially if you try things like where your lines would have crossed, you'll see sort of funky things between add edge and add vertex. It's you never specify the reference point. All of the computation we did here are all relative to some imaginary reference point, but we never specify the reference point exactly. It's always a good idea if you're thinking about creating a G-polygon to identify for yourself what that reference point is before you draw the line segments. Yeah, you just figure out what the size of the image is by asking its height and width, and then you need to specify scaling factor to make it large enough to do the whole screen. Yeah, so let me actually show that to you right now. Here's so add vertex, we just returned the polygon. We set its fill to be true. We set its color to be magenta. We write it out in the middle of the screen. Not a whole lot of excitement going on. The one thing that's important to note is when we add the diamond to our canvas, the location that we give for adding it to the canvas is the location of the reference point. So every time that we do something with the polygon, once we've created it, the x, y location that we specify for the canvas is the imaginary reference point. So here our middle point was get width divided by 2, or sorry, get width divided by 2 is this way. Get height divided by 2 is the center of the screen. And because we use the center as the imaginary reference point for the polygon, it actually shows up in the center of the screen. So actually using G-polygons a lot of times is just convenient, even if you want a circle, because you want to specify the reference point of the circle to just be in the center of the screen as opposed to its corner. If you really want to do, we should talk offline. We should talk offline. Yeah. There's a bunch of things we could do. Essentially, there's a bunch of stuff with polar coordinates that I should mention. We're not going to deal with, so if you read in the book about like polar coordinates and theta and all that, we're actually not going to do it in this class. So if you're like, oh, polar coordinates, like, yeah, polar scares me. It scares me too, right? Like polar coordinates you only need to worry about if like you're a bear or you're in the Antarctic, right? We're just not going to worry about polar coordinates. We're just going to do Cartesian coordinates, but it's easier to do rotations if you think polar, okay? So in terms of adding an edge, we're going to do the same thing for create diamond using edges instead of vertices. So if we want to create a diamond adding edges, we have to still specify the first vertex just like we did before. And now the edges, what I'm specifying for the values for the edge is an offset in the x and y direction. So my offset in the x direction is width over 2, so that would move here. And my height is negative height over 2, so that would essentially move over here because it's relative to my last point. It's not relative to the imaginary reference point. Okay? And so basically if I sort of follow this all the way around, what I do is I add edges. Again, after I add that last edge, the polygon is closed for me automatically. I get back the same diamond. I'm just now doing it with edges instead of with vertices. Same sort of deal. I make it magenta because magenta is a fun color, and I write it out to the screen. Okay? So that's G-polygon. Now, things get a little more funky. And the thing that gets the funkiest of all, right, it's kind of like the George Clinton of graphics classes, is G-compound. And so what G-compound is going to do, anyone know George Clinton? All right, a couple of folks. At least it's not like totally lost. G-compound basically is, as you'd imagine, it's a compound shape. It allows you to take multiple other shapes that you've seen and put them all together and treat that one thing as one object, which is very convenient sometimes if you want to draw something complicated and then move it all around the screen, for example, or rescale it. Okay? So adding objects, the way a G-compound works is you add objects to a G-compound just like it was a canvas. So just like you've done before where you say, I have some canvas and I put these little objects on it and it draws pictures. If I have some G-compound and I add a bunch of objects to it, I now have this compound thing that encompasses all of those objects. Okay? So you can now treat the whole compound as one object though, which is the whole reason for having this. And I'll show you the example of this in just a second. So similar to a G-polygon, a G-compound also has a reference point that when you add objects to the G-compound, you add all the objects relative to some imaginary reference point that the G-compound has. Okay? And finally, how do you display this thing, right? So when you add things to a G-compound, they're not displaying on the screen. You need to take the G-compound and add it to the canvas just like all the other rects or ovals or whatever you did before. And when you place it relative to its reference point and it will draw all the objects that it encompasses. Okay? So let's actually just see what that looks like. So let's draw a little face. Oh, a little face. And so you can see we're going to use some different things here, right? We're going to have an oval. We're going to have a couple other ovals as the eyes. Hey, triangle. What should we use for the triangle? Polygon, right? Some people like 3 lines. No, G-polygon. It's your friend. Really, it's a fun time. And here's a little rectangle for the mouth. Okay? So what we're going to do with this is we're just going to go ahead and take a look at a class G-face. Okay? So this gFace class that I'm creating, this is a whole separate class. I'm going to create this class, gFace, as extending G compound. So a gFace is going to be a G compound. Okay? And what I'm going to do is I'm going to have a whole bunch of constants here that just specify like the width of the eyes and height of the eyes and all the sort of features of the face. And I'm going to have some objects that comprise my little G compound. So I'm going to say, well, the head's an oval, and the left eye and the right eye are both ovals, and the nose is going to be a polygon, and the mouth is going to be a rectangle. These are all my private instance variables. Okay? That's just the variables I'm going to use to keep track of the things I create and add to my G compound. So the compound has a constructor, which is just the same name of the class. It's gFace, and what it's going to take in is a width and a height, because I want to allow the face to automatically be resizable, which means all the stuff that I create that's part of the face needs to be in terms of the width and height that are passed in, so it will resize itself depending on whatever width and height the user gives me. So first thing I do is I say, hey, the head's going to be an oval, and the oval is basically just a circle that's of size width comma height, right? It's going to be the size of the whole head, so whatever size you give me is the size of the head. The left eye is going to have the eye width times width, so it's going to scale by whatever width you give me for the face. I'll scale it by eye width, and same thing for the height. I'll scale by eye height. And I'm going to create two eyes, left eye and right eye. Notice at this point I haven't placed where left eye and right eye are. I've just created them. Okay? The nose is going to have a function or a method associated with it called createNose that's going to return for me a G polygon. And so we'll take a brief digression down here to take a look at createNose. So what's createNose going to do? It's going to have some width and some height for the nose. It's going to create a new polygon and add vertices to construct the nose. So the first vertex it's going to add, and we're going to think of the center of the nose as being the reference point, the imaginary reference point. So the first vertex is sort of the height or the bridge of the nose. It has the same x-coordinate as the center of the nose if we think of some imaginary triangle. Here, actually, let me just draw a little triangle so we can use the board. Here's the nose. Here's our imaginary reference point. Where's our first vertex going to be? It's going to be up here. That's the same x-coordinate as our imaginary reference point and half the height. You can just imagine these two are now equal, waving of hands. It's going to be half the height upward. So that's going to set this first vertex here. And then where am I going to set the next vertex? The next vertex relative to the center is going to be width divided by 2 over. So width divided by 2 over. And then in terms of height, if we can see it over here, it's going to be height divided by 2 downward. So this is the next vertex, and then the last vertex is over here, and that's going to give you your little triangle for the nose. Okay? So when we create the nose, I'm losing my chalk, we're going to return that polygon that's created here, because this method is returning a G polygon, and the place that gets assigned is back up here where we actually have a nose. Okay? So we say the nose is whatever I get back from createNose, it's going to be the polygon for my nose. And the nose is, of course, scaled by the size of the face, right? So we have nose width and nose height that's scaled the size of the face. And the mouth, last but not least, is just a rectangle. Again, is scaled by the height and width of the face, given the mouth width and the mouth height. So now I've created all my little pieces. How do I put them together to create the face? Well, when I call add methods inside of here, what I'm creating, right, I'm creating a new G compound, right? What I'm creating here is gFace, which extends G compound. Since it extends G compound, that means all the methods that exist for G compound extend here. This is not a graphics program, right? This is G compound. So when I call add here, I'm not adding it to the graphics window. I'm adding it to the G compound. So add head at 0, 0, my imaginary reference point, okay, for this face is going to be this upper left-hand corner of the bounding box. Okay? So if I say add head is 0, 0, if I think of this as 0, 0, and this is an oval, it's going to add the oval here because what I'm specifying is the upper left-hand corner of the oval. Okay? Now, where am I going to add other stuff? I'm going to add the left eye to this kind of funky equation over here, but basically all it's saying is I take a quarter of the width of the face and subtract from it the eye width scaled by the size of the face divided by 2. So basically what it's going to do for the x-coordinate is do something on sort of this part of the face. It's going to bring it over a quarter from where it would have been relative to the center of the screen. And then I'm going to also do something relative to the height, for the left eye and the right eye, they're both going to be at the same height, where I basically just look at a quarter of the height down the face is where those eyes are going to show up, and I have to do some accounting for the eye height. So if my face were really big, my eyes still show up at the right place. So it's just a little bit of math. You can sort of trace through it by hand if you're interested, and the exact coordinates where these things are going is really not that important, as long as we get a right layout that looks like a face. The important thing is all these things are relative to our little reference point at 0, 0, which is the reference point for the face, right? We haven't put anything on the canvas yet. The nose is just going to be at the center, so nose is going to be halfway over on the width and halfway over on the height. So if this is our reference point over here, we go halfway over on the width, halfway down on the height. That's the very center of the circle. And because when we created our G polygon, the imaginary reference point of our triangle was the center, it places it relative to the imaginary center point of the triangle. So we get the triangle right in the middle of the face. And last but not least, we're going to add the mouth. And the mouth is basically going to go near the bottom of the face. It's actually going to go in the center of the face. This is just basically finding the center point for the X shifted over by the size of the rectangle, and then it's going to be 3/4 of the way down the circle, which is kind of how we get this. Okay? So we add all of these things relative to this reference point, and now if we actually want to display this, we need to write some program that displays it. So we'll have a program called draw face. And all draw face does, it's pretty simple. It says I'm going to pop up a little pop-up in the middle of your screen. I'm going to have a graphics program that's going to have some face width and face height. And what I'm going to do is I'm going to create a new face, giving it the width and height. And where do I want to place this face on the screen? I want to center it on the screen. The reference point for the face, though, is not the center of the face. It's this upper left-hand corner. So I need to figure out, relative to that upper left-hand corner, I'm losing another piece of chalk, how to center the face. So what do? I get the width of the screen, I subtract from it the face width, and I divide by 2. That's kind of the classic thing you did when you were trying to center, say, a rectangle. You would take the width of the screen, subtract off the width of the rectangle, divide by 2. What it will essentially do is figure out the coordinate to place this guy so this whole thing is centered in the screen. And we do essentially the same thing in the y direction as well. So we look at the height of the screen, we subtract off the height of the face, and divide by 2, and that gives us how much we should go down. Okay? So again, when we finally place this on the canvas, we're placing it, when we specify the point on the canvas, that point is the reference point of the whole G compound. Okay? So any questions about that? I could have actually done it as just creating a G polygon object and adding everything inside of another program, but I wanted you to actually see it as extending a class, just because that's a common way of doing the decomposition. You say this thing that I'm going to create really as a G compound, so I'm going to create it as a derived class of G compound. It's the more common way of doing it. Oh, sorry. Yeah, so you can think of there's a Z ordering in a compound that's just like a canvas. So you actually you can have layering of objects, and objects will include other objects in the compound. And it's the order in which they're added. So the funky thing also about doing this is, remember our friend the bouncing ball? Let me just refresh your memory with the bouncing ball. I like the bouncing ball. So I'm running. Here's our friend the bouncing ball. Come on, bouncing ball. We're bouncing. You're like, ooh, the bouncing ball got bigger since last time. Yeah, I changed one constant. It got a little bigger. That's okay. You wouldn't have remembered if I didn't tell you. Like, how many people are like, oh, I measured the number of pixels. Well, here's bouncing ball. And what's the whole beauty of having G compound and creating a new class out of G compound? Because I don't want bouncing ball anymore. Ball is boring. I want a bouncing face. How do I create a bouncing face? Hey, I got this class over here, G face. That's a good time. Instead of a ball, I'm going to have this thing be a G face. Like, don't do it, Marilyn. All right, well, now that I do that, right, I'm still going to call it ball just so I don't have to change the ball everywhere in my program. There's one other thing that happens, though. When I create the ball, I'm no longer creating a G oval. I'm creating a G face. Notice G face still takes a width and a height, so my parameters are unchanged. The only other problem is a G compound does not satisfy the criteria or the interface for being fillable. So this little thing to make the ball fillable and set the fill of the ball to be true, you'll see like, oh, a little error condition over here, because G face or a G compound in general doesn't have a notion of filling the whole compound, so we get rid of that. And now we save this puppy off, And we're going to run, and let's see what happens. First thing, right, with just modifying like 20 seconds worth of code, we didn't get an error. And we'll run bouncing ball. Dun, dun, dun. And now I have bouncing face. Yeah. Scale to be just the right size. Life is good. 3 lines of code to modify. That's the beauty of object-oriented composition, is when I have something that's a ball, and a ball is a G object, or a G oval is a G object, and I have something else that's a G object, I can just slam one in for the other. Bouncing Stanford logo? Yeah. Bouncing face of your roommate? Yeah. You can do it. All right, we're just going to not bounce anything else for the time being. But one thing that's even more interesting than just being able to bounce stuff around is what we refer to as event-driven programs, okay? And all an event is when you do something in the world that's an event. Like when you went to Stanford, that was a big event. Like, you know, you got your big packet in the mail and you opened it up and you're like, oh, I got into Stanford, I'm going to Stanford, or maybe like you gnashed your teeth and tried to figure out where you were going to go or whatever. Or some of you were just like, oh yeah, I'm going to Stanford for sure. And that was an event, and you know, there was like cake and celebrating and the whole maybe. I don't know, maybe you were like, oh, I got to go to Stanford, bummer. But it was an event. And in some sense, your life is a program, and it's driven by events. These little things happen, and it changes the course of your life. Hopefully coming to Stanford changed the course of your life in a good way. In terms of actual programs you write, there will also be events that will change the course of your program. But these events are a little bit more minor than, say, getting into Stanford. There are things like when the user interacts with a computer, like clicking the mouse or pressing a key. Those are events that happen on the computer. And your program should be able to detect certain events that are going on and respond to them by doing various kinds of things, like, say, when you're writing your breakout program. Okay? The way we be able to determine if an event has taken place is kind of a clandestine operation. It's kind of like we're in the CIA. And we got to say, oh, did an event take place? Well, I don't know a priori if an event took place. I need to send out my minions. And your minions are called your listeners. Your listeners are something you put out there that says, I'm here, I'm listening for events, is anything going on? And unless you put out your listeners, you're deaf to what's going on in the world. It's kind of like you weren't listening, you weren't watching the mail for that Stanford packet, and the Stanford packet came and you just never checked the mail and you never knew. And no one was going to tell you because you didn't put out your listener for the Stanford packet. On the computer, there's 2 different kinds of listeners we think about. There's a mouse listener and a key listener, which gets events from the mouse and events from the keyboard. And so the way we create our listeners is in our program very early on, we either say add mouse listeners or add key listeners. We can actually say both to listen for both things. And these are methods that are supported by graphics programs, for example. Okay? Now, in order to use these listeners, you need to have a library added in your program that deals with events, and that's the Java awt.event.star. So in your programs that use events like your listeners, and we'll look at events in just a second, you'll need to have this little import line in there. And this is all in the book. You don't have to hurriedly copy it down. A bunch of people have asked for slides, and I was hesitant to post slides on the web because I think like if slides are up there, people will not come to class. So first of all, how many people would like me to post the slides on the web? How many people will continue to come to class if I post the slides on the web? Yeah, it should be all those same hands. Good times. All right, I'll post them on the web then. All right, so there are certain methods of a listener that get called when an event happens. And this is the funky thing. Up until this time, all of your programs have been what we refer to as synchronous. There are some series of events that happen, and you know the next event is going to happen or the next method is going to get called after the last method got called. You're now entering a world called the asynchronous world, which means you don't know when things are going to happen, right? Events happen. Like you might have been waiting for weeks for that Stanford little, acceptance letter to come. You didn't know when it was going to come. Eventually it came, but you didn't know. And there were some sad people who we won't talk about right now, but if you're out there watching on video, it's fine. It's perfectly okay. You were waiting for the Stanford acceptance letter, and it never came. That happens. It's not a bad thing. You're still listening. You were active. You took a participatory role in life. That's what you should do. It's a good thing. But you didn't know when or if it was going to happen. And that's what an asynchronous event is. It happens, and you don't know when it's going to happen. You just got to be prepared when it happens. You're like, I'm gung-ho. When it happens, it's going to happen, and I'm going to be there because I'm listening for it. That's what you want to think about. Okay? So let's look at a simple example of an event-driven program called Click for Face. You're like, what does that mean? But it probably involves the face. Yes, in fact, it does. So click for face. That could mean anything. Click for face. This is an example of event-driven program. What this is going to do is it's going to bring up a blank screen, and every place we click on the screen, it's going to put a little face there. That's why it's click for face. All right, so how does this work? Well, first of all, click for face is a graphics program. Okay, it's going to draw a face wherever the user clicks the mouse. Now, here's the funky thing. There's a couple funky things that happen in this program. This program has no run method, because there is nothing we need to do in terms of a bunch of sequential steps in this program. All we're doing is we're waiting for events. We're waiting for someone to click the mouse. Until they click the mouse, we got nothing to do, except for we got to be listening for that mouse to get clicked. So there's a method called init. And init automatically gets called when a program starts. And you might say, well, that sounds a lot like run. What's the difference between run and init? The way you want to think about the difference between these is run is when you're actually doing some real work. Init is generally when you're just saying, there's a few things I need to initialize. Like I need to put my little ear out there to be listening for things, but there's not any real work I'm going to be doing in the program. It's a subtle distinction. It's not a big deal if you mix the two up, but there is a difference, just so you know. Okay, and we won't, ding you for it heavily or anything like that. Just so you know, most of your programs will probably have the run method. Like in Breakout, you'll have a run method. You won't have init. It's not a big deal. Okay? So all init does is it says, hey, I got to be listening for those mouse events. So it adds mouse listeners. It just says that. And that means now I'm listening for the mouse. What happens when the mouse gets clicked? Here's the funky part. Okay? There's a method called mouse clicked. And mouse click takes in a parameter of type mouse event. Now, if you're paying very careful attention to this program, you will realize that nowhere in your program do you actually call the mouse clicked method. You're like, if I never called the mouse click method, why am I writing it? This is what asynchronous events are all about. This particular method has a special name that is understood by the listener. When it hears a mouse click, it will call your mouse clicked method for you. That's why it's asynchronous. You don't know when it's going to get called. All you know is if there's a click, it will get called, and you will get this parameter called mouse event. And what a mouse event has is information about that mouse click. Namely, you can ask the mouse event, which we're just calling E for event, get X and get Y, and that gets the XY location of where the mouse was clicked on the screen. If the mouse was not clicked in your graphics window, you don't hear that, because your listener can only listen in your graphics program. It's not listening to your whole computer. So don't worry if you're like, oh, I'm reading email. Is it like listening? No, it's OK. It's just looking for little clicks in your graphics window. And so what we're going to do when we get some mouse event is, hey, our friend the G face. We're going to create a new G face. That sounds like it should be a rap group or something. As a G face. Maybe that should be. All right, we won't get into that. And it's just going to be a circle with a face diameter, which is some constant I specify, not a big deal, of 30. I'm going to create some new round G face, and I'm going to place it at the XY location where the mouse was clicked. Note that the XY location that I set the face is this relative location of the face. The face will not show up exactly in the middle where I click the mouse. It will show up slightly to the right and down of where I click the mouse. But just to show you that this works, let's click for face. It's like bowling for dollars. We're clicking for face. We're running, we're feeling good. Any questions about asynchronous events, by the way? Let me just run click for face. Question? If you have two programs running simultaneously? Yeah, so while your program is running, if you get these asynchronous mouse clicks, the mouse click method will get called for you. Yeah. It will stop momentarily for you to deal with that method called mouse clicked, and then it will continue execution. Yeah. So here there's nothing in the program yet because we haven't clicked yet. Click for face. So you can spend like weeks. You're like, yeah, there's a click here. Oh, I'm going to put some faces on top of each other. It's like a party over here. Yeah, click for face. That's it. If I click out here, I don't get any faces, right? I go to some other application because it only listens for events inside here. Okay, so that's click for face. There we go. No, because you don't know where it would return it to, right? You're not the one that called it. Someone else called you. So you're like, hey, you called me. Here's a good time. Have a candy bar. And it's like, I don't want a candy bar, and it gets really upset. So, but I hope you wanted the candy bar. So yeah, you don't return anything. But it's a good thing to think about. So that's click for face. Now there's a whole bunch of things you can actually listen for. It's not just clicks, okay? But the general idea is first you add your mouse listeners. That's critical. Common thing people do is they forget their listeners. And they're like, hey, I'm clicking for face, and I'm not getting any face. And it's not because the face doesn't love you. The face loves you, I know. I was right in the face at like 3 a.m. last night. It loves you. And then what you need to do after you have your mouse listener in there, and then you add definitions for any listeners you want to have. And so here's the common set of listeners for mouses. There's mouse clicked, which you just saw. That's called whenever the user clicks the mouse. There's mouse pressed. What's the difference between a click and a press? The press is that the mouse button has been pressed down. It has not yet been released. So if you want to do something like a drag where you hit the button and you move the mouse around and then you release it, you can check for pressed and released. So a press and a release together is a click. So you can actually do kind of multiple things. You can do something when the mouse is pressed. You can do something when the mouse is released, and that'll also count as a click. Okay, so mouse clicked, mouse pressed, mouse released, mouse moved. Every single pixel that the mouse moves, it's like, oh, mouse moves, mouse moves, mouse moves. Yeah, I can't even do it fast enough. That's how fast it goes. It tells you that the mouse moved. Okay? And mouse dragged is when someone actually clicks on something and then moves the mouse while holding down the button. In fact, we'll say that the mouse has been dragged, which is like mouse moved, except this is only happening when the button's down and someone's moving the mouse. But all of these take the same kind of mouse event, and so you can get the XY location for where that click happened or where the mouse recently moved to. Okay? And that's going to provide you the data about the event. So let's look at another one. Let's actually track the mouse. You're like, oh, that wily mouse has gotten away from me. How do I track the mouse? Mouse tracker might be real useful for breakout, just in case it wasn't clear. What the mouse tracker is going to do is basically, I'm going to have a run method here because there's actually some work I want to do other than just having listeners. What am I going to do? I'm going to create some empty label. I'm going to make the font for that label real big so you can see it. I'm going to add that label at a particular location on the screen because it's an empty label. When I start out, nothing will show up. And then I listen. I set up my mouse listeners, and I'm like, woo, mouse, mouse. And what I'm checking for is mouse moved. That's the only listener that I'm setting up here. If mouse moves, I get some event. I'm going to change the text for that label to be mouse with the XY location it moved to. Okay? And I need to keep track of my label both here and here. So I need to keep track of the label in between method calls so I actually have my label be a private instance variable. Okay? So if I run this puppy, you know, it's like 10 lines of code, but check out just how cool it is. Well, after it runs. You're like, how cool is it, Maron? We're going to track the mouse. We're running. Oh. Yeah, see, it moves off the screen, stops tracking. Moves back into the screen, starts tracking. One thing you can do if you're just totally bored is, can you get to 0, 0? It was much harder to do last night. It was like 3 a.m. I'm like, I should be preparing a lecture, but I want to see, can I get to 0, 0? I'm like, you know, an hour and a half later, I was like, there it is. And then I wept. So besides the mouse, there's also things you can do with the keyboard. Okay, so the keyboard is also your friend. So, returning to our friend the slide, besides tracking the mouse, we can also do things with the keyboard. And you're like, hey, Maron, for breakout, do I need to do anything with the keyboard? Not in the basic version of breakout. But if you want to do like the cooler version of breakout, where your paddle, besides just being a paddle, can like shoot at the bricks and take them down, some people have done that in the past. It makes the game much easier. But it's fun. You can listen to keyboard events. So keyboard events work just like mouse events. You add a listener, but the listener you're going to add is key listeners. It's perfectly fine for a program to add both mouse listeners and key listeners. Why do you have to add these to begin with? And the reason why you have to add these is because your program really needs to know, do I need to pay attention to these things? Because it actually requires some work on the part of the computer to pay attention to these things. Because one thing you might just think a priori is, this whole listener thing is just dumb, Maron. Like, any program I run, yeah, if I'm pressing the keyboard, it's just know about it, right? No, not necessarily, right? If you're writing a piece of software that needs to run really fast and doesn't care where the mouse is, why should you have it worry about where the mouse is or worry about what keys are being pressed? So that's why this is a thing that's important to remember that you need to put in there, but doesn't come in by default, because it's actually programs where we care about efficiency and we don't care what the user is doing, which sadly enough is many programs. We don't have listeners. Okay? So for the key listener, there's 3 things you can check for, or these are the most common ones. There's actually a few more that are in the book, but these are the ones you really need to worry about for most things. There's key pressed, which is called when the user presses a key. Okay? There's key released, which is when they let go of the key. So key pressed is when they push it down. They have not necessarily let go of the key. Key released is they've let up on the key. So you can actually do funky things where when you press something, like the screen goes black, and then your roommate leaves and doesn't know what you're doing, and then you lift up the key and it comes back. You can actually do that. Key typed is basically like a click. It's press and release together. So when you press and release a key, that generates a key typed event. What you get in this E that you're getting is an event. It's not a mouse event, it's a key event. And key event is an object which has information about, for example, which key was pressed. And the book goes into the details of which key was pressed. But I want to show you a simple example of this where we don't even care what key was pressed. All we care is that a key was pressed. So yet another example. Woohoo! And I can actually just close PowerPoint. So what we're going to do is we're going to drag objects around. What does drag objects do? So drag objects is a graphics program, and what I'm going to do is create a rectangle on the screen and add it, create an oval on the screen and add it, and add mouse listeners and key listeners. And you might see this and go, Maron, why is this an init method as opposed to a run method? Shouldn't it really be a run method because you're doing some work? Yeah, probably. You can. It's 6 of one, half dozen of the other. The book actually has a similar program to this. It's not the same program, but a similar program. They call it init over there, so I just made it init to kind of match the book, so you're not like, oh, Maron's slides in the book are just completely wrong, and they get in this death struggle. No, it doesn't really matter that much. Okay? But we create the rectangle, we create the oval, we add them both to the screen, we add the listeners, both the mouse listener and the key listener, and now here's what we're going to do that's funky. We're going to allow objects to be dragged on the screen. What does that mean? That means when you click on a rectangle on the screen and you move your mouse holding down the button, that's called a drag, we're going to have the rectangle move with you. Woohoo! Rock on. So mouse dragged. Mouse dragged is going to get some mouse event. Now there's a little bit of funkiness in here with this little G object thing. What does that mean? So I'll get back to that in just a second by first showing you what this G object actually is. So what I'm going to keep track of in my program is a generic G object. Okay? And you might say, but Maron, we don't create generic G objects. Yeah, that's because this variable G object is either going to be the rectangle or the oval. It can be either one. They're both G objects. So the common denominator is that they're G objects. So this object, this variable, is going to keep track of what object is currently being dragged on the screen, what object I clicked on, so I know what object I'm actually dragging, whether it's the oval or the rectangle, or that I haven't clicked on any object at all. G point is basically just something that holds an X and Y location. It's a very simple object that we haven't talked about till right now, but basically all the G point is, it's a little tiny object and it has an X and a Y location in it. And so I can set the X and Y location in the point, and I can say, give me, with getters and setters, get the X and Y location. It's just a little convenient encapsulation. I could have actually had this be a separate variable X and a separate variable Y. I just created the G point so you could see a G point. And I'm going to have a little randomness in my program too, so the random generator will once again rear its ugly head. And so I get an instance of the random generator. You'll see we're going to generate some random colors in just a second. Okay? So with that said, how does this mouse pressed and mouse drag thing work? Mouse pressed says when someone clicked the button, right? They have not yet released the button. It is not a full click. It's just that the mouse was pressed. The mouse was pushed down. I get this event. And that event E basically has an X and Y location associated with it. As you saw in the previous example, I can get the X and Y location separately. There's a way where I can just say E.getPoint, and it gets the X and Y location together in a little point object and gives that back to you, which is why I created this thing called a G point so you can see it. It's just a nicety that gives you the X and Y at the same time. And when I say, hey, get that point, and what I want to do is get the element at that point. So wherever you clicked, call getElementAt. That will return to me the topmost object at the point you clicked. If it's the rectangle, it will give me back the rectangle. If it's the oval, it will give me back the oval. If there is no object at the point I clicked, I get back something called null, L-U-L-L, and that gets assigned to GObject, which means your GObject, there is no thing, there is no object there. Null is just a way of referring essentially to no object. But you can assign any object the value null to say there's not really an object here. Okay? And so getElement will either give you the oval, the rectangle, or null. Okay? GetElementAt, something you're going to use in breakout. Pay close attention. So what happens after the user clicks? If I get an object at the place they clicked, I now see, are they moving the mouse? If they're dragging the mouse, after they click, if they move the mouse at all, that generates events that are mouse dragged events. So it gets called with the position of the mouse that the mouse has been dragged to. First thing I checked, are you dragging an actual object? When you click the mouse, did you click it on top of an object? If you did, then gObj is not null. If you didn't click it on an object, then it is null. So, hey, nothing to see here. You didn't click on an object, and now you're trying to drag around. You got nothing to drag, buddy. Sorry, thanks for playing. I'm not going to do anything. But if you did click on an object, then what I'm going to do is move that object. And remember, move is in relative coordinates. It says, move this object relative to where it was before. So I say, get the x location and the y location that the mouse has moved to from this event, and subtract off essentially the last place that the mouse was, which is where the mouse actually clicked on this object, so I get some relative amount of movement. Okay? And now, after you've moved the mouse, I need to say the mouse is actually at a new point now, so I update the last point that the mouse was at to be equal to wherever the mouse was actually moved to. So last is always the last location that the mouse was either dragged to or got clicked on. Okay? Last but not least is I want to change the color of the object that you last clicked on, or that you're dragging, to a random color if you type any key. So I don't care what key you type. I'm not actually going to look at what the key event was. But if you typed any key, key typed will get called. And if your object is not null, I'm going to set its object color to be, or the color of that object to be some random color that I'm going to get my random color generator, or my random number generator is going to give me random colors. So let me run this so you get a sense of what's actually going on, how these pieces fit together. It's like you could create a whole drawing program now. All right, so we're going to drag some objects around. So when this puppy starts off, we get an oval and a square, which both start off black, right, because I didn't set their color. They happen to be slightly on top of each other. If I click on the rectangle and move it, yeah, notice how it tracks the mouse when I move it. When I now click off the rectangle and try to move around, nothing happens. Or if I click here and try to drag, I'm holding the mouse button down, nothing happens. If I click on the oval and move it around, it gets moved around. Now I want to be funky. I press a key. The last object I dragged gets assigned a random color. That's kind of fun for about 3 seconds. All right. If I click on the other object and move it around, you can actually see the oval was put in front of the rectangle, and the Z ordering is not changing by me moving the object around, right? I never say send to front or send to back or anything like that. I could do that if I wanted to bring an object up to the front, which is kind of the behavior you might be used to from other applications when you click on something and it comes to the front. Not here, because I'm not changing the Z order, so it's just, back over here. But the last thing I clicked on, I can also get random colors and change its colors. Yeah, it's just, yeah, so much fun. All right, any questions about that? We're dragging, we're clicking, we're changing colors. Yeah, I could have done set location. I just need to do a little bit more math for set location because I need to figure out to set the location of the object relative to where the mouse was clicked inside the object and its coordinate sort of up in this corner. So one final thing I want to show you before you go, because now you've seen all the code to actually be able to create a simple game like Breakout. But here's another simple game just to show you another example of stuff going on. Okay? I call it the UFO game. I gave you all the code for the UFO game. You might recognize this game. Yeah, it's sort of like Space Invaders Lite. Do you remember anyone remember Space Invaders? Like 2 people. Yeah, this thing is like coming down the screen toward you, and you're in the middle, and you get to shoot these little shots at it every time you click on the mouse. And if it ever reaches the bottom of the screen, you die. But if you hit it, I'm coming so close. If you hit it, it's gone. Okay? Thank you. Hours of work. Let me just show you a little bit of the code so you can understand. This will be important for Breakout. When the code runs, how are you going to create the effective animation and also other stuff going on at the same time? I'm going to give each object in the world a chance to do something. I'm going to call move UFO to allow it to move. Move bullet to allow it to move if there's a bullet in the air. Check to see if there's a collision between these 2 things, and wait before I do this whole cycle again. So I just continue to do this cycle over and over, right, until my game is over. And the way that I check my game is over is basically that little square got down to the bottom, or I actually shot it and got a collision. I'll leave it to you to look at the code, because if I go through the code in excruciating detail, I'll probably get breakout questions. But you have all the code, so you can understand how hopefully it works, and you can leverage it for breakout. So I'll see you on Friday.